over the last 50 years or so. We had, here's the Phillips curve for the 1960s, when the economy starts out in the early 1960s, bouncing around here. Then, as the Kennedy-Johnson administration gets expansionary and wants to get the economy moving again, and then even more so with the Vietnam War, the economy's unemployment rate falls and its inflation rate rises. So at the end of the 1960s, we have not, the 2% inflation rate that the economy had grown used to in the 1950s, but an inflation rate approaching 6%. And we had not the kind of 5 to 7% unemployment rate around which the economy had fluctuated in the 50s and the early 60s, but the unemployment rate was getting down to 3.5%. If you think of this red Phillips curve, as indeed I think you should, of one corresponding to expectations of inflation around 2%, by the late 1960s, you haven't seen 2% inflation in 4 years, and what you have are inflation outcomes about 6% or so. And it's hard to see how, in any sense, that can be a stable economic situation. And indeed, it wasn't. Right, the early 1970s see the Phillips curve up here, with it hitting the 2% inflation line, not with unemployment at 5.7%, but with it hitting the 2% unemployment line with inflation, with the 2% inflation line with unemployment up here around 6.5%. That expectations of inflation have risen, and the Phillips curve has moved up, and even more so in the mid-1970s, as after the 1973 Arab-Israeli War and the first oil shock, the economy winds up here on its Phillips curve, and even more so in the end of the 1980s, when it seems like the economy is working its way along the Phillips curve way up here with enormous expectations of inflation, with expected inflation at 12% per year or so, at the end of Jimmy Carter's and the start of Ronald Reagan's presidency. That tells us that we want to do something else, right, with this particular equation here. And the natural thing to do is to say, okay, well, let's impose rational expectations. Let's see what happens if we require that the expected inflations that appear on the right-hand side of the equation are the same thing as the actual inflation that appears on the left-hand side of the equation. Let's require that expectations of agents in the economy be correct, that people on average not be surprised either positively or negatively. And so let's just erase this little e for expected from this equation here. Let's just move this pi for actual inflation over to the right-hand side. And if we do that, and if we do a little algebra, we get this equation here. The equation for the rational, expectationally consistent equilibrium inflation rate, what the inflation rate is going to be. And it's going to be equal to the Federal Reserve's inflation target, plus this misperceptions term that we've seen before, the difference between the Federal Reserve's unemployment benchmark on the one hand and the economy's natural rate of unemployment or another, divided by this phi term, which tells us how fast and how far the Federal Reserve reacts to high inflation by raising the unemployment rate. And it's in this sense that by the time everyone has figured out what the Federal Reserve is doing, and by the time that all expectations have converged, and if nothing else disturbs the economy, that we can say that the Federal Reserve is going to be able to control the inflation rate. That it can set this target, and as long as its views of what the natural rate of unemployment are realistic, and as long as it backs up this target by raising interest rates sufficiently far whenever inflation gets above the target, the Federal Reserve can tell us what the inflation rate is going to be, and what it tells us will be true in the long run. That is, all of this is true only in the long run. And as John Maynard Keynes wrote famously back in 1924, he was kind of sick of economists who would only talk about the long run. The long run is very fine, right? And the long run is a good thing. But when the tsunami is coming, to say that in the long run the tsunami won't have any impact on the average level of the average sea level on the average tide is not terribly helpful when the tsunami is coming. When the tsunami is coming, you want to know how high it is and how long it's going to last and where it's going to go. And so this kind of long run analysis, while it has its place, Keynes said, is the start, right, and not the end of what any economist is going to do. And we're also going to want to ignore Keynes's strictures about how this Phillips curve stuff is very unreliable. That Keynes would have said, well, it's an important part of market psychology, and market psychology is important, but market psychology is chancy stuff. And we really do not want to rely on market psychology. We don't want to spend too much time thinking about market psychology. We want to do science. We want to do economics. We don't want to wave our hands and saying, well, suppose people expect X, Y, and Z. Actually, we do. Actually, we're not as cautious as Keynes. And we do want to say what's going to happen to the economy if you have various kind of types of expectations formation in the economy. And so we're going to consider three types of expectations. We're going to consider static expectations. Situations in which inflation expectations in the market are well anchored and do not change, right, like the 1960s. We're going to consider adaptive expectations, in which inflation expectations are what inflation has recently been in the past. And we're going to consider rational expectations, in which inflation is expected to be what it is actually going to be. And that's what we're going to be doing for the rest of this lecture. For static expectations, we take the 1960s. People, for the natural rate of unemployment of about 5.5%, a little more, people expect the inflation rate to be 2% throughout the 1960s, and they don't update that, they don't change that, they just sit there with that being their static expectation. They think of that even when they think that's the case, even when inflation crosses 4%. They think of that even when inflation hits 6%. They simply say expected inflation is 2%. It always has been. We know this. We're not going to worry about it. And that produces this downward sloping relationship between the inflation rate on the one hand and the unemployment rate on the other. You can see where that comes from in this Phillips curve equation. Right? If expected inflation is just this static constant, then when unemployment goes down, the inflation rate is going to go up. When unemployment goes up, the inflation rate is going to go down. If expected inflation doesn't move, and if the natural rate of unemployment doesn't move, you have exactly the kind of relationship that we saw here. However, and that's why we go to adaptive expectations, this thing isn't stable under stress. Everyone who is, say, selling a bond or selling their labor in 1969, expecting that inflation is going to be 2% when it's actually 6%, is going to be in real trouble. Because they show up for work the following year and they find that inflation has been 6%, so they're being paid 4% less than they had actually thought they were going to get in real terms. Everyone who lends out money thinking that a 4% interest rate is a healthy cushion above a 2% inflation rate finds they're not earning as much interest as the process of price increase is eroding from their principal, that they're losing and not gaining money by making 4% interest rates. So that people, when they realize what inflation is, they tend to change their expectations because they're not going to make contracts that make fools of them, that make fools of themselves forever. And so that's how we switch from static to adaptive expectations. Expectations in which you take whatever inflation has been in the recent past and you say, that's my expectation of what inflation is going to be in the future. And we see that in the 1970s. Not necessarily a smooth thing of the process. It looks very much as if the Phillips curve takes three discontinuous jumps, right? An early 1970s jump, a mid-1970s jump, and then a late 1970s jump. But still, after the inflation rate's been 4% for a while, been in the 4 to 6% range for a while, people raise their expectations of inflation up to 4%. After it's been in the 6 to 12% range, people raise their expectations of inflation up to 9%. After it's been in the 8 to 14% range for a while, people increase their expectations of inflation up to 12%. And then the same process works in reverse. As Paul Volcker says, I am going to keep unemployment as high as is necessary in order to keep inflation at or below 5%, which he does from the end of 1982 on. As Paul Volcker does this, eventually people give up their Phillips curve, according to which the expected inflation was 12% or so, and gradually change their expectations and move down to a world in which expected inflation is 5% or so, which is where we are when we end the 1980s. Now let's try to figure out how this economy, in which you have a Phillips curve on the one hand, but you have a central bank with a monetary policy reaction function engaged in leaning against the wind to control inflation on the second hand, and in which you have these adaptive expectations of inflation on the third hand, how such economy works. And let's suppose that inflation for some reason jumps to someplace higher than its initial level, jumps to a relatively high level, a level much larger than the Federal Reserve wants to see. And actually, I don't want that pi star. I want that, to be a pi t for our target level of inflation. I tell you, why it is that Microsoft Office 2011 is no faster than Microsoft Office 1984, when the computer has a million times as much processing power altogether, it remains a mystery to me. But it is still the case. They have managed to take an incredible amount of processing power and use it all up, doing what I do not imagine. I cannot imagine. All right. But let's suppose that we have our adaptive expectations of inflation. So let's suppose that something has happened to boost inflation to someplace significantly higher than our Federal Reserve's target rate of inflation, and suppose that nothing else happens to disturb the economy thereafter. What then happens? Where then does inflation go? Right? How does the economy kind of progress? What's its path of dynamic evolution in such a system? And the way to do this is to march through forests of algebra. So we start up here. We start up here with our equation for what the level of inflation is going to be in the world in which we had a monetary policy, in which we had both an expectational Phillips curve here and a monetary policy reaction function there. From there, we derived this particular equation for what the inflation rate was going to be. And this is that equation for what the inflation rate is going to be. With one difference, we've added a little t down here, below pi for inflation, to tell us that this is inflation in year t, because we're going to want to be considering of a whole bunch, about a whole bunch of different inflation rates, at a whole bunch of different times. And we're also going to want to put a t on inflation expectations as well, because expected inflations differ over time, right, from piece to piece as well. That's the first thing we do. We write down our old equation for what the inflation rate is in the model with a monetary policy reaction function and an expectational Phillips curve, and we say we are going to keep track of what happens at different times. The next thing we do is our adaptive expectations assumption. We say that expected inflation at time t is equal to actual inflation at time t minus 1. The expected inflation at time t is equal to actual inflation at time t minus 1, and simply plug this pi t minus 1 in for the expected inflation term to get this particular form of the equation here. Then we're going to want to subtract off the long-run level of inflation from both sides of the equation. That after all, to some degree, we're interested not so much in the absolute value of inflation, but in where inflation is going relative to its long-run stable equilibrium value. And we often find that we can get cleaner and simpler equations if we simply subtract off long-run averages. It's a bet. It's generally a good bet. We make it here. We simply subtract off the long-run rate of inflation from both sides. On the left, we do that by simply getting this minus pi star here. On the right, we subtract minus pi star from the numerator of this equation, but because of the denominator, that's not a whole pi star when we've added this term. We also need to subtract a bit more. This second term here comes by subtracting the rest of what we need in order to subtract pi star from both sides, where you'll remember that our pi star here, this expectationally consistent long-run inflation thing, simply depends on the difference between unemployment and its target unemployment and its natural rate, and on the inflation target. So that gets us to here. And then we're going to want to boost the algebra even more by replacing this particular pi star, not this one is happy, this particular pi star, this particular long-run inflation rate, by its definition. So here in this line, we've simply taken this pi star here and replaced it with u star minus u0 over phi plus pi t. And with the idea that maybe then, if we're lucky, we'll manage to get some of these other terms to cancel out. And indeed we do. This first line here is simply a repeat of the last line on the previous graph. We then expand these terms, distribute them, multiplying this term here by this first term and this time here by the second term, and we arrange all of our little terms together, 1, 2, 3, 4, and then we notice they all nicely and neatly cancel out, right? All four of them. So what we've done is we've taken this equation here for what inflation is in our model with a monetary policy reaction function and an expectational Phillips curve. We've assumed adaptive expectations of inflation. We've then just said what's the difference between the inflation rate and its long-term expectational consistent equilibrium level. We've worked through the algebra, and we found a huge amount of stuff has dropped out. And what we're getting with is you take what the difference between inflation was and its long-run level last time, You divide that by 1 plus beta phi, by this kind of thing that's greater than 1 that comes out of our model that's based on its coefficients, and we get the gap between inflation and the long-run value this year. And you can view this kind of equation in two ways. First, you can say, gee, these people must have been very clever in order to successfully rig things, that you work through this enormous forest of algebra. You work through this enormous forest of algebra here, and yet you wind up down here with something very simple. And the second is to say, no, that's not it at all. This is actually a reflection of a fairly deep principle in the world, which is that when the Federal Reserve takes steps to curb inflation by leaning against the wind, by raising unemployment through raising interest rates when inflation is high and lowering it by lowering them when inflation is low, then you get then you get that inflation does indeed converge, that the Federal Reserve can actually control inflation, and that this measured and gradual way of attempting to deal with it does produce a gradual approach to the long-run inflation level, with each year you getting an additional factor of 1 plus beta phi closer to what inflation's long-run value is going to be. You can look at it both ways. Right? This is both a clever way of setting up the model so that the answer is simple, and it also is a fairly deep truth that a central bank that is patient and gradual will be able to bring inflation under control, and that in such a model, inflation does head for the long-run value, in which it's equal to the Federal Reserve's target, plus this misperceptions term if the Federal Reserve doesn't understand the structure of the economy properly. So the conclusions, and these are two equations that you also are going to need to know how to work on the final, is that if you have this model with an expectational Phillips curve, with adaptive expectations, and with a monetary policy reaction function, then we can tell where the economy is going in terms of inflation and how fast it's going to get there. Where it's going is for this expectationally consistent equilibrium inflation level. This is where the economy will be in the long run. As we see here, each year, provided there are no additional shocks to the economy, the gap between the actual inflation rate and this long-run expectationally consistent equilibrium level shrinks. How fast does it get there? Well, say this year's gap between actual inflation and the long-run expectationally consistent value is smaller than last year's gap by this factor 1 plus beta phi, by 1 plus the product of the parameters in the Phillips curve implication of the monetary policy reaction function equation. And that will be and so you're going to be heading there. How fast you're heading there depends on the slope of the Phillips curve and on the aggression of the central bank. But you are going to be heading there. You are going to be converging. Let's work through an example, of this. Let's say we're going to start with a 10% inflation rate. And that's going to be the inflation rate last year was 10%. So that's what expected inflation is this year. It's 10%. And let's use our standard parameters for this, that our beta, our slope of the Phillips curve, is 1/2, so that for each additional percentage point that the unemployment rate rises, inflation falls by 0.5%. And let's suppose that the slope of our monetary policy reaction function is 1, so that for each additional percentage point that inflation rises, the central bank raises the unemployment rate by an additional percent. And let's say, what? No, phi is 1. The phi is set phi to 1, so the 0.5 looks like it's beta, but it's actually beta times phi. And let's say that the Federal Reserve misjudges the economy, that the actual natural rate of unemployment is 6%, but that we have a Federal Reserve staff by Democrats, appointed by Kennedy and Johnson. And they're incredibly over-optimistic, and they think the target unemployment rate they should head for is 4%. Yeah? Yep. That's going to be inflation in year T. Yeah. And so suppose the target inflation rate is 2%. What's inflation going to be in year 1 then, if we started out with inflation at 10% in year 0, and this adaptive expectations, expected inflation this year is just what inflation was last year? Well, we take our 10% inflation, that's expected inflation, and we plug it in. We take our 2% inflation target for the central bank aiming at, we plug it in. We plug in our 6% and our 4% for the natural rate and for the target rate of unemployment and plug them in. We crank through and we get out that in year 1, inflation is going to be 8%. So that we started in year 0 with inflation at 10%, well above our target, and in year 1 we find that inflation is 8%. Now let's suppose that nothing further happens to disturb the economy. The process simply works its way through. And let's suppose we then move on from year 1 to year 2. Now the nice thing about this equation is that then nothing changes except for expected inflation. Right? That actual inflation in year 0 was 10%, so expected inflation in year 1 is 10%, and actual inflation in year 1 is 8%, so expected inflation in year 2. So expected inflation in year 2 is 8% as well. So that tells us that actual inflation in year 2 is going to be 6 2/3%. And then if actual inflation in year 2 is 6 2/3%, expected inflation in year 3 is 6.67%, actual inflation in year 3 will be 5.78%. And you can crank your way through years 4 and year 5, by which point inflation's fallen down from 10% to 4.79%. Where are we headed for? Well, we're headed for an inflation rate of 4%.